What's up? It's Mr. Wicklehouse. Who else would it be on these videos? I guess it could be some total and complete stranger, but that's not who it is today. It's Mr. Wicklehouse, and today we are simplifying square roots, otherwise known as simplifying radicals with an index of 2. Alright, so what's that mean? Oh, let's see. So what is a radical? A radical is an operation related to exponents. It is an exponent written in a different form. For now, let's concentrate on what they look like, and we'll worry about the exponential form of it later. Okay, so every radical has this weird check mark looking thing. You guys know that already. And then it has something called an index right here on the outside that's just right above this tail end of this check mark. Alright, for today we're going to be using an index of 2, otherwise it's known as a square root. Okay, typically with the square root, although it could be written like this, of some number, we usually just write it without the index on it. So it looks like this. Okay? Alright. Beyond the index, the thing underneath of the square root is called the radicand. And where the majority of the work that we do with these radicals is going to happen underneath of the radical with the radicand when we're simplifying these things. Alright, so let's do some examples here, if we can see them anyway. Okay, get this thing into focus, and bam, there we go, save. Alright, this is our first example. So when I'm doing these, I look at the number as one thing, and I look at the variable as something else, and I kind of work on them separately. And the idea here is that we're looking for pairs of things underneath the radical. Now there's two different ways to think about this. I'm going to go over both ways with this first one, and then I'm going to do the way that I prefer from every example here on out. Okay, so I'm going to look at this number 27. Okay? And I'm going to look at it twice so that we could do the two different ways to think about this. So the first way to think about this is doing the prime factorization of this number, which means, and I'm sure you guys have done this before, is I'm just going to break this down until I've got nothing left but prime numbers. Okay? So this broke down into 9 and 3 and then 3 and 3. So now I've got these 3 3s here. And what I'm looking for is I'm looking for pairs of numbers. Okay. So I see that I've got a pair of 3s here. Okay. Which means that this pair is going to come outside as a 3. And then I'm going to leave the other 3 inside with this. Now I'm partially done with simplifying this one, but let's go up and look at how we break it down a different way. I'm still thinking to myself, what number times another number is going to give me 27? But the key here to doing this is thinking, can one of those numbers be a perfect square? In other words, a perfect square is a number that is a number multiplied by itself to give you another number. It's a perfect square. So perfect squares are numbers like 1, 4, 9, 25. Oh, I missed 16. In there, 36, 49, let's see, 64, 81, 100, and so on. They're just numbers like 1 times 1, 2 times 2, 3 times 3, 5 times 5, 4 times 4, 6 times 6. So you can see going down the list here that these numbers are just the most perfect numbers multiplied together by themselves to give you another number. Okay, perfect squares. The reason why that's important is because when I take the square root of a perfect square, I'll get one of these numbers. So I know that 9 is a perfect square, and I know 9 times 3 is 27. Well, because 9 times 3 is 27, then I know that I've got a 3 outside and the square root of 3x squared. Okay, left inside. Anyway, that's the way to deal with the numbers. Okay. Now let's deal with the variable. This one's pretty easy. This is x times x, which means that I could pull an x out here, and I get 3x square root of 3. Obviously, that's going to be the same here. I'm just looking for pairs of things. That's the idea here. Okay. Let's look at this example. I know that 9 is a perfect square, which means that I can take a 3 out. But this time it's a little bit different because there's a number out front here. In any case, this 9 is 3 and 3, a pair of 3's, pull the 3 out, I get 11. Then I'm going to multiply the 3 times the 11, and I get 33 square root of x. Okay? So all I did was I broke down what I could, pulled the pair out to where there was a single number, and multiplied it by what was outside. That's really all you're doing with these things. You're trying to break down what's inside, move it outside, and then you'll multiply it by whatever's outside. Okay, let's look at another one. Alright, here's some with some extra variables in it, and there's not any numbers in this one. Okay? Alright, well, this has 3 x's in it. This has 4 y's. So this is x, 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 y, 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 y. I got one pair of x's, and I've got 2 pairs of y's. So that means I can pull 1x out. So I'll have 3x times x. And then since I have 2 pairs of y's, and I can pull 2 y's out, and then I'll have an x left underneath, because that's the only one all by its lonesome. So then this is going to end up being 3. X times x is x squared. Y times y is y squared, square root of x. Again, all I'm doing is taking what's underneath the radical and simplifying it as much as possible. Okay? Alright, here's one. This one's kind of ugly. Look at the number 132. Blech. What can I do with that? Well, if you don't know right off the top of your head that there's a number that goes into this that is a perfect square, we could do the prime factorization. I know that 12 times 11 is 132. 11 is a prime number, so 12 factors into 4 and 3, 4 factors into 2 and 2. There's the only pair that I've got, so I could pull a 2 out front. Now I've got 2 times 10 times z cubed. Y to the 7th. This is y times y times y times y times y times y times y. There's 1, 2, 3 pairs of y's with 1 y left over. The z won't break down anymore. Okay. So what I've got left underneath, now let's start with this. This is going to be y times y times y. And the square root, what I've got left underneath is a 3 and 11, a y, and a z. So 3 times 11 times y times z. Which then, let's simplify this. This is 2 times 10, which is 20. Y cubed z cubed square root 3 times 11 is 33 y z. And there we go. These obviously could get more complicated, but just remember, break down piece by piece by piece, and you'll be able to do any of these that you need to do. You're looking for pairs of things, break the numbers down, do the pairs. There you go. That's how you do it. I will talk to you later.